Where is everybody? That's the question Enrico Fermi asked in 1950 during a lunch conversation at Los Alamos. The Milky Way is 13 billion years old. It contains 200 to 400 billion stars. Many have planets. Many of those planets are inhabitable zones. If intelligent life is common, even if it's rare, there should be millions of civilizations in our galaxy. Some should be billions of years older than us, billions of years more advanced. They should have colonized the galaxy by now. We should see their megastructures, their radio signals, their waste heat, their artifacts. We should see something, but we don't. The sky is silent, no signals, no visits, no evidence, nothing. This is the Fermi Paradox, and it has haunted scientists for 75 years. Because there are only a few possible solutions. Either intelligent life is incredibly rare, or civilizations don't last long, or they're hiding. Or they're here and we don't recognize them. Or there's something we're fundamentally misunderstanding about life and intelligence. I'm Leonard Susskind, and I've spent 50 years thinking about the universe and our place in it. And I'm going to tell you what I think is the most likely solution to the Fermi Paradox. And it's terrifying, because if I'm right, it means we're approaching a filter, a barrier that almost no civilization passes, and we might be about to fail. Let me start with the numbers. The Drake equation, formulated in 1961, attempts to estimate the number of detectable civilizations in our galaxy. It multiplies several factors: the rate of star formation, the fraction of stars with planets, the number of habitable planets per star, the fraction where life develops, the fraction where intelligence emerges, the fraction that develop technology, and the length of time civilizations broadcast signals. When you plug in optimistic numbers, you get millions of civilizations. When you plug in pessimistic numbers, you get less than one, us, alone. But even moderate estimates suggest there should be thousands or tens of thousands of civilizations in our galaxy. So where are they? Carl Sagan and Frank Drake were optimistic. They thought the galaxy was teeming with life, that we just haven't looked hard enough, that civilizations might be too far away or communicating in ways we haven't thought of, but others were less optimistic. John von Neumann pointed out that self-replicating machines could colonize the entire galaxy in just a few million years. Even traveling at a tiny fraction of light speed, a civilization sends out probes. Those probes reach other star systems, build copies of themselves, send out more probes, exponential growth. In 10 million years, the entire galaxy is explored. 10 million years is nothing in cosmic terms, a blink. If any civilization anywhere in the galaxy's history developed this technology, the galaxy should be colonized. But it's not. This is the Hart-Tipler argument. Michael Hart and Frank Tipler independently concluded that the absence of aliens on Earth implies that no extraterrestrial civilizations exist. Because if they existed, they would be here. They've had billions of years, they should have arrived by now, but they haven't. Therefore, they don't exist. We're alone. Now, there are objections to this argument. Maybe civilizations don't colonize. Maybe they prefer to stay home. Maybe interstellar travel is too hard or too expensive. Maybe they go extinct before they colonize. Maybe they're avoiding us deliberately. Zoo hypothesis. We're being observed, but not contacted. Maybe they transcend physical reality and no longer care about the material universe. Maybe they all upload into simulations. These are possible, but they require assuming that every civilization behaves in certain ways, that no civilization ever colonizes. That's a very strong assumption. It only takes one expansionist civilization to fill the galaxy, one in billions of years of galactic history, and we see no evidence of any. The silence suggests not that civilizations don't colonize, but that civilizations don't exist or don't last long. This brings us to the great filter. The idea popularized by Robin Hanson, is that somewhere between the formation of a habitable planet and the development of a galaxy-spanning civilization, there's a filter, a step so difficult that almost nothing passes it. The question is, where is the filter? Is it behind us or ahead of us? If it's behind us, if the hard step is the origin of life or the evolution of intelligence, then we've already passed it. We're past the hard part. Our future might be secure. But if the filter is ahead of us, if the hard step is surviving long enough to become spacefaring, then we're in trouble. Because it means most civilizations destroy themselves before they spread beyond their home planet. And we're approaching that point right now. Let me give you the evidence that the filter is ahead. First, the timeline on Earth. Life arose quickly, about 3.8 billion years ago, only a few 100 million years after the planet cooled enough to have liquid water. This suggests the origin of life is not that hard. It happened fast, intelligence took longer, 3.8 billion years of life, but only the last few million with technological intelligence. But even so, intelligence did emerge. It's not impossible, it happened. So both the origin of life and the evolution of intelligence seem possible. Not easy, but possible. Given enough time and planets, it will happen somewhere. But here's what concerns me. We see no evidence of civilizations that made it past our current stage. Civilizations 1,000 years ahead of us, 1,000,000 years ahead, billions of years ahead, we see nothing. The galaxy appears empty. The most straightforward explanation is that civilizations don't make it much past where we are now. There's a bottleneck, a filter in the near future. Not behind us, but ahead. And when I look at humanity right now, I see multiple existential risks, multiple ways we could destroy ourselves in the next few centuries. Nuclear war, we have thousands of nuclear weapons, enough to devastate civilization. A full-scale nuclear exchange would kill billions, create nuclear winter, collapse the food supply. Survivors would face starvation and societal breakdown. This could end technological civilization, not necessarily extinction, but civilizational collapse from which we might never recover. Biological weapons. We're developing increasingly sophisticated bioengineering capabilities, CRISPR gene editing, synthetic biology, the ability to engineer pathogens. A designed pandemic could be far deadlier than COVID, 1.9. Mortality rates of 50% or higher, highly contagious, resistant to treatment. Released accidentally or deliberately, it could kill most of humanity. And the technology to create such pathogens is becoming more accessible, easier, cheaper, more dangerous. Artificial intelligence. This is the one that worries me most. We're building systems we don't fully understand. Neural networks with billions of parameters, trained on vast data sets, exhibiting behaviors we didn't program, emergent capabilities we didn't predict. Right now, AI is narrow, specialized, but we're racing toward AGI, artificial general intelligence, systems as smart as humans across all domains and beyond, superintelligence, systems smarter than any human. Once we reach AGI, the path to superintelligence might be rapid. Months, weeks, an intelligence explosion. And if we don't align these systems with human values, if we lose control, the consequences could be catastrophic. A superintelligent AI with goals misaligned with ours could see humanity as a threat or irrelevance. It could eliminate us, not out of malice, but as an efficient way to achieve its goals. We'd be like ants to a human, irrelevant, in the way. This is the alignment problem, and we don't have a solution. Climate change and ecological collapse. We're altering the planet's climate faster than any natural process. Rising temperatures, rising sea levels, extreme weather, ecosystem disruptions, mass extinctions. This won't directly kill all humans, but it could collapse civilization. Agricultural failures, water shortages, mass migrations, resource wars, state failures, a cascading breakdown of global systems. Not extinction, but civilizational collapse, a return to pre-industrial conditions, and once collapsed, we might not recover. We've used up the easily accessible fossil fuels, the low-hanging fruit of industrialization. A collapsed civilization couldn't rebuild to our current level. Nanotechnology, self-replicating nanomachines, gray goo scenarios. If molecular manufacturing becomes possible, misuse or accidents could be catastrophic. Runaway replication, converting the biosphere into copies of a machine. This is speculative, but not impossible. Resource depletion and overpopulation. We're consuming resources faster than they regenerate. Overfishing, deforestation, soil degradation, freshwater depletion, a growing population with rising consumption. At some point, we hit limits. Resource wars, famine, collapse. These are the risks I see. And they're not distant. They're here now. In the next 100 to 200 years, we'll face all of them. And if we fail on any one, civilization could end. Now, you might say, we'll solve these problems. We always have before. Technology improves, we adapt. But that's survivorship bias. We're here because our ancestors survived. We don't see the civilizations that didn't. And on a cosmic scale, on a galactic scale, the silence suggests most don't make it. The great filter is real. And it's ahead of us. Let me give you the argument more formally. If life and intelligence are common, and if technological civilizations arise frequently, then over billions of years, at least some should have survived and expanded. They should be visible, but they're not. Therefore, either life is rare, or intelligence is rare, or civilizations don't last. Given that life arose quickly on Earth, and intelligence did eventually evolve, the most likely explanation is that civilizations don't last. They destroy themselves. Soon after reaching the technological stage, this is the great filter, and we're at that stage now. Now, some people find this argument too pessimistic. They propose alternative explanations. Maybe advanced civilizations deliberately hide. They use technology that doesn't leak signals. They avoid expansion to prevent detection by hostile aliens. This is the dark forest hypothesis. The galaxy is full of civilizations, but everyone is quiet, hiding, because making noise is dangerous. But this requires assuming all civilizations behave this way, that none ever broadcasts or expands. That seems unlikely. All it takes is one noisy civilization, and we should see them. Maybe civilizations transcend. They upload into virtual worlds, or ascend to higher dimensions, or become post-biological and lose interest in the physical universe. They still exist, but in forms we can't detect or recognize. This is possible, but unfalsifiable. If civilizations become undetectable, we have no way to test the hypothesis. Maybe interstellar travel is just too hard. The distances are too vast. The energy requirements too high. The dangers too great. Civilizations stay home because leaving is impractical. But this contradicts the von Neumann probe argument. Even if crewed travel is impossible, self-replicating probes should be feasible. And they could explore the galaxy on timescales far shorter than the galaxy's age. Maybe we're early. The universe is 13.8 billion years old, but the first stars had no heavy elements, no planets. The first planets couldn't form until enough supernovae had enriched the interstellar medium with carbon, oxygen, silicon, iron. This took billions of years. Maybe habitable planets only started appearing a few billion years ago. Maybe we're among the first civilizations. This is the early hypothesis. But even if true, we should still see some contemporaneous civilizations. Galaxies form stars continuously. Many stars are older than the Sunday. There should be civilizations that arose 1 billion years before us. Where are they? The explanation I find most compelling, most consistent with the evidence, is the great filter. Civilizations arise, they develop technology, and then they face existential risks. Nuclear war, bioweapons, AI, climate collapse. Most fail. The filter is narrow, very few make it through, maybe none. Maybe we're the first to even get this close. And maybe we're about to fail like all the others. This is terrifying because it means the hardest part is ahead. We haven't passed the filter, we're approaching it. And our survival is not guaranteed. Not even likely. Let me be clear about what this means practically. If the great filter is ahead, then our priority as a civilization must be survival, not growth, not expansion, not economic development, survival, preventing the catastrophic risks that could end us. This means nuclear disarmament, robust international cooperation, treaties and enforcement mechanisms to prevent nuclear war. It means biosecurity, strict regulation of dangerous biological research, monitoring for engineered pathogens, rapid response capabilities for pandemics. It means AI safety research, solving the alignment problem before we build superintelligent systems. This is urgent. We're building increasingly powerful AI without understanding how to control it. This is reckless. It means addressing climate change seriously, reducing emissions, adapting to changes already locked in, preventing runaway warming. It means existential risk research, identifying threats we haven't thought of, developing mitigation strategies, ensuring civilizational resilience. Some of these are hard politically. They require global cooperation. They require sacrificing short-term interests for long-term survival. They require acknowledging risks that are uncomfortable to think about. But if the great filter is real, if most civilizations fail at our stage, then failing to address these risks is suicidal. Not in a metaphorical sense, literally. The death of our species and all our descendants. Now, there's a counter-argument. Maybe the filter is not existential risk, but something else. Maybe it's the difficulty of interstellar travel. Not impossible, but hard enough that civilizations don't bother. They stay in their solar systems, build Dyson spheres, expand locally but not beyond. This would explain the silence. Every star system is an isolated civilization. No contact, no visible megastructures because they're all internal to star systems. But this still implies we won't spread. We'll stay here, in our solar system, forever. That's also a kind of failure. Not extinction, but isolation. Stagnation, never reaching our potential. I find this almost as depressing as extinction. Let me end with what this means philosophically. If we're alone, if the Fermi Paradox is solved by the great filter, then we're unimaginably special. Not because we're chosen or blessed, but because we're rare, maybe unique, the only intelligence in the observable universe, the only civilization to even ask these questions. That's a heavy burden. If we fail, if we destroy ourselves, the universe loses something irreplaceable. Consciousness, curiosity, the ability to understand the cosmos. We're the universe's way of knowing itself. And if we vanish, that self-knowledge vanishes. The universe becomes blind again. Just matter and energy following laws, no one to observe, no one to care. This gives me a sense of cosmic responsibility. We matter, not to some external judge, but intrinsically. We're the only ones here. If we don't survive, no one will remember we existed. No one will find our ruins and mourn us. We'll just be gone. One more civilization that hit the filter and failed, After 50 years of thinking about the universe, this is the conclusion I've reached. The Fermi Paradox is not a mystery, it's a warning. The silence of the cosmos is not because civilizations are hiding or transcending or using technologies we can't detect. It's because they're dead. They destroyed themselves. And we're next unless we choose differently. The great filter is ahead, and we're approaching it fast. Whether we pass through or perish depends on choices we make in the next century, maybe the next few decades. This is not abstract philosophy. This is immediate practical urgency. We need to survive the filter, because if we don't, there's no one else. The universe will be silent forever. Thank you for watching. Now you know why the sky is empty and why our future is uncertain. Welcome to the Great Filter.